Okay, so this is the start of Unit 3, which is really the meat of what most of you are here for, which is the dosage calculations. We do have, being fall semester, we do have an extra Friday this semester. So this is the unit that I usually put that extra Friday in because it's the one that's the most important, really, as far as what most of you are going to go on to do after this. So some of the things that are very important to us, some processes that are very important to us coming from the last couple of units. One is a unit conversion. Sometimes given the fancy word, dimensional analysis. And all it really is using the units on the numbers to tell us what calculations have to be done. For example, if we were doing a length measurement, if we had, I don't know, 132 inches, and I wanted to convert that into feet, the way we would do it, we'd make the 132 inches into a fraction. We're going to multiply by a conversion factor. We want the inches to go away, so we're going to put inches on bottom so they will cross cancel out, and we're changing it into feet, so the feet go on top. The relationship is 1 foot equals 12 inches. So now this is telling us exactly how to do the conversion. 132 times 1 foot is 132 feet. 1 times 12 is 12. And then you divide that out. 132 feet divided by 12 is 11 feet. So we do this process where we set it up and we cancel out the units when we want to change units. We want our answer to be in a different unit. We started out with inches and we want to end up with feet. An example of that for medical dosages might be we might have something that is 2 milliliters, or 2 milligrams per 5 milliliters. And we have a dosage that is calculated as need to administer 12 milligrams per minute, I should say. And you want to figure out how many milliliters that is per minute. The 12 milligrams per minute is a fraction. 12 milligrams over 1 minute. We talked about this when we did our rates and ratios. We want to know, as we said, milliliters per minute. So since we're changing the units, we want a different unit. That's when we do this process here. The minutes are going to stay the same. What we're changing is the milligrams. We want to change the milligrams to milliliters. So we want to get rid of the milligrams. So milligrams on bottom. Milliliters are going to go on top. And our relationship is 5 milliliters per 2 milligrams. Notice it's upside down compared to what that ratio was, but that's the way we needed it for our conversion. So the milligrams do cancel out. 12 times 5 milliliters is 60 milliliters. 1 minute times 2 is 2 minutes. So that's 60 milliliters per 2 minutes, or if we divide it out, that is 30 milliliters per minute. We've made a unit conversion. We use that process when we want to change the unit. We started out with milligrams per minute. We want milliliters per minute. So we cancel out by multiplying the fractions. The other major process that we can have is where we want the same units, we just want to change one of the numbers. For example, let's say we have a rate of 32 milliliters per minute, and we want to know how long is it going to take for 96 milliliters to be infused. Here we have milliliters and minutes. Over here we have milliliters, and we're looking for time, it just as well be in minutes. So we're not changing either of the units. We have milliliters and minutes to start with, and we're going to end up with milliliters and minutes. We're looking for our answer in minutes. So we're not changing the units. We're changing the amounts. We're changing the numbers. This is where we use a proportion. So this is going to become 32 milliliters in 1 minute equals, over here, it's 96 milliliters in X minutes, or however many minutes we're going to find. Notice again, the units, milliliters and milliliters, minutes and minutes. Both of the units are staying the same. What's changing is the numbers. We want to change it from 32 milliliters to 96 milliliters. And then we want to see how that affects the number of the other item in our ratio, in our rate. And this is where we would cross multiply and divide, or just cross multiply, depending on how you want to look at it. So 1 times 96 is 96. If this is x, 32 times x is 32x. Dividing or solving 32x equals 96, we would divide by the 32. X equals 3. So it would take 3 minutes to infuse 96 milliliters. Or we might have that concentration of 2 milligrams per 5 milliliters again. And you might ask, so how much, if you want to administer 24 milligrams, what volume do you need? Same thing. We're looking for how many milliliters would you administer. So again, we're starting with milligrams and milliliters, and we're ending with milligrams and milliliters. We're not changing the units. We have the same number of units. We just want to see how, if we change from 2 milligrams to 24 milligrams, if we change that number, how does it change the number for the milliliters? So that's, again, a proportion. So this is 2 milligrams over 5 milliliters. On the other side here, milligrams will be on top, milliliters on bottom. We know the 24 milligrams. So milliliters is what we're looking for, X milliliters. So we'll cross multiply. 5 times 24 is 120. We can do 2 times X is 2X, or we can just divide by the 2. We know that's what we're going to do anyway. 120 divided by 2 is 60. That'll be 60 milliliters. So those are the two main processes. Unit conversion, or conventional analysis, that is if we are going to change one of the units. Change one or more of the units. And the other process is the proportion. And that's if we're going to have the same units but we're going to change one number. And of course, when we change one number, it affects the other number. So what we're trying to see is if we change one number, how does the other one change? So that's going to be our first obstacle, is keeping those two processes straight. When do we do each? And those two processes pretty much govern all of dosage calculations. Now we're going to look at some other possibilities, like the dosage calculation formula for some things. I'm not a huge fan of it because I don't like throwing out formulas. Bless you. I like just having basic concepts and figuring it out from there because it's more reliable for me because I can remember the basic concepts. I cannot remember the thousands upon thousands of formulas I've seen for things throughout my life. So the first real medical concept we're going to tackle here is something called a dilution. And a dilution is just a ratio. And the dilution itself is a ratio of parts of a concentrate that could be a pure medication, could be a more concentrated form of the medication, you know, a 60% concentration or whatever. Or it could be a sample, a blood sample, a urine sample, or something like that. To total parts of the solution. So a dilution is that particular ratio. Now, we discussed this a little bit when we did the ratios several weeks ago, that there are two other ratios that will appear there. And we'll explore that here as we do some examples. So our first dilution we're going to look at is, let's say that we have a 1 in 5 dilution of, now for a medication, what we're going to do is we're just going to use the term serum. Serum is just a generic term for medication. Could be lidocaine, could be insulin, could be any medication that you want to use. We're just going to say serum. In another term that we're going to use, NS. NS has a couple of possible interpretations. NS is sometimes, I'm going to write it up here, neutral solution. Neutral solution means it has no medicinal properties. It does not contribute anything other than volume to the solution. Or sometimes they refer to the NS as normal saline. Normal saline is nothing more than a pH balanced water. Basically, it's a purified water is all it really is. Again, no medicinal purposes. All it does is contribute volume. It dilutes out the solution. Sometimes it just be referred to as sterile water. That's normal saline. So anyway, we have a 1 in 5 dilution of serum in saline. So what that means is there is 1 part serum in 5 total parts solution. Now there are 2 other ratios there, as I said. What portion of that solution is saline? Well, 5 parts is the total solution. If 1 part is the serum, the other 4 parts, 5 minus 1, have to be the saline. So if 1 out of the 5 parts is serum, 4 out of the 5 parts has to be the saline. So that's probably the easiest ratio to get from our dilution, other than the dilution itself. The other one that's sometimes useful is if it's 1 part serum to 5 parts solution, and there's 4 parts saline, of course, in that 5 parts of solution, the ratio of serum to saline is then 1 to 4. Depending on what the actual question being asked is, any one of those 3 ratios might be applicable. I mean, this is the dilution itself here, but from the dilution, we may be required to derive one of the other 2 ratios to actually solve the problem. So let's take a look at some examples. So in a 1 in 6 dilution, of serum in saline, how many parts of serum are required to constitute or create 120 milliliters of solution. So how much serum is required to constitute 120 milliliters of solution? So we have a 1 in 6 dilution. So 1 to 6. What does the 1 represent again? Serum. The 6 represents total solution, right? So the 1 is the parts of the serum. The 6 is the total parts in the solution. So looking up here, we have the 120 milliliters. What does that represent? Does that represent either of those? Does it represent the serum or the total solution? It represents the total solution. So before we continue with this, are we asked to find the serum, the amount of serum? Yeah, how much serum? How many parts serum? So this is what we're asked to find here. So this ratio does help us get to what we need to know. So we'll cross, multiply, and divide. 1 times 120 divided by 6 is going to be 20 milliliters of serum. So the question might come out, how do I know that's milliliters? Well, this dilution is a ratio. How do I know it's a ratio? There's no units here. It's just 1 to 6, 1 in 6. There's no units there, it's a ratio. If there were units there that were different, it would be a rate, if you recall. So over here, if this is a ratio, on the other side, whatever the units are on bottom, the units on top have to be the same, and vice versa. So I know that has to be 20 milliliters. It'll take 20 milliliters of serum to constitute 120 milliliters of solution. So again, in a 1 in 6 dilution of serum in water and saline, how much serum should be mixed with 200 milliliters of saline? So our dilution is a 1 in 6 dilution. Again, I label everything. The 1 is the parts of serum. The 6 is the parts of the total solution. So obviously in problems like this, there's always something we have the amount for and something we're looking for. In this case, we're looking for how much serum. So that is something we need. We need the serum. That's in our dilution. That's good. But what are we given? 200 milliliters of NS. Is that the total part solution, the total volume of the solution? No, it's not. That's the amount of saline. So the dilution ratio itself is not the ratio we want to solve this problem. We could use it if we wanted to, and I'll come back to that. I'll show you how we could use it. But technically, the ratio we really want for this problem is the ratio of serum to saline. What's that ratio going to be? 1 to 5. Very good. Serum is 1 part. If there's 6 parts total solution, 6 minus 1 means the other 5 parts are the saline. So the ratio of serum to saline is 1 in 5. So we have the 200 milliliters of saline. That'll go here with the saline. And we're looking for the amount of serum. So we can cross, multiply, and divide. 1 times 200 divided by 5 is 40 milliliters. Now I mentioned we could have used this ratio over here, the dilution ratio itself, if we wanted to use the dilution ratio. We could have done this. Actually, you know what? We couldn't have. It wouldn't have worked. We would have had, and this is a case where we had to convert it because the 200 milliliters does not represent either the serum or the solution, so there's nothing we could have done with that. How much saline is required to create 280 milliliters of a 1 in 7 dilution of serum in saline. So how much saline is required to create 280 milliliters of a 1 in 7 dilution of serum in saline? So 1 in 7 dilution. The 1, again, represents the serum, the parts of serum. 7 is the parts total solution. $280 milliliters. What does that represent? Total solution. Are we looking for the amount of serum? No, we're looking for the saline. So once again, this isn't really the ratio we want. The ratio we really want is the saline to total solution. What's that ratio actually going to be? 6 and 7. If 1 out of 7 parts is serum, the other 6 parts has to be the saline. So then we have the 280 milliliters is the total solution still. We can cross, multiply, and divide. 6 times 280 divided by 7 is going to be 240 milliliters. So as it would take 240 milliliters of saline to create the 280 milliliters of that dilution. Now here's one where we could have used the dilution. If we cross, multiply, and divide over here, 1 times 280 divided by 7 is 40 milliliters. We know that 40 milliliters represents the serum. We would just have to subtract. 280 minus 40 gives us the 240 milliliters of saline. But we just have to make sure we remember to do that additional step so that we answer the actual question. So in a 2 in 9 dilution, I'm not going to keep saying of serum and saline. I think you guys get the point that that's what it is. In a 2 in 9 dilution, how much saline is to be mixed with 50 milliliters of serum? So we're going to start again with the dilution, which is, bless you, 2 over 9, 2 in 9. The 2 represents what? Serum. 9 represents total solution. So, in our problem, bless you, we have 50 milliliters of serum. That would go here. Are we looking for the total solution? No, we're looking for how much saline. So this isn't the ratio we want. What ratio do we really want? Okay, well, do we need serum? Yes, we need the serum because we're given the serum. So we want the serum, is instead of the total volume, we want saline. We know the serum and we want to find the saline, so we need the ratio between them. So the serum's still going to be 2. The saline is 7. 9 minus 2. Notice that the 2 plus 7 still adds up to the 9 for the total solution. So then, we have 50 milliliters. Where does that go? That's the serum, so it goes on top. And we can cross, multiply, and divide. 7 times 50 divided by 2 is 175 milliliters. Now, according to this ratio, that represents the saline. Is that what we were looking for? Yeah, how much saline? So 275 milliliters of saline is what we need. Or 175 milliliters of saline is what we need. Any questions? Find the dilution ratio if 80 milliliters of serum are in 400 milliliters of solution. So dilution, of course, is serum to total solution. Do we know the amount of the serum? $80 milliliters of serum, right? So yes, we know the amount of serum. Do we know the amount of total solution? Yeah, 400 milliliters of solution. Now, before we do anything else here, we have to check. Are they both measured in the same units? Yes, they are. So we can cancel out milliliters and milliliters. We can cancel them out. They have to be the same units or it's not a ratio. Next, turning this into the dilution ratio is just a matter of reducing. 80 and 400 can both be divided by, well, both be divided by 10 if you want to start there. If it was 80 over 40, they can still both be divided by, so 8 over 40 is divisible by 8, gives you a 1 in 5 dilution. So this is a 1 in 5 dilution. Find the dilution if 200 milliliters of serum are in 2 liters of solution. So again, dilution, we want serum in total solution. We have 200 milliliters of serum, 2 liters of solution, so 2 liters total solution. Are they in the same units? No. So before we can do anything else, we must put them in the same units. Can I convert one into the other? Sure can. Probably easiest to leave the 200 milliliters and convert 2 liters into how many milliliters? 2,000. Very good. Now, of course, the milliliters will cancel out. They divide out. And both of those can be divided by 200, giving me 1 in 10. So that is a 1 in 10 dilution. Find the dilution ratio if 120 milliliters of serum are mixed with 360 milliliters of sterile water. So again, our dilution is going to be serum total solution. Parts serum to parts total solution. Do we know the serum? Yeah, 120 milliliters. Do we know the total solution? No, but yes. We're not given that amount, but we can find it by doing what? Add them together. 360 milliliters of saline, 120 milliliters of serum. We're just going to add them together. So it's 120 milliliters to 480 milliliters. And now the milliliters can divide out. 120 and 480 can both be divided by 120. Give us a 1 in 4 dilution. What do you think? Now, a little side note here. A little bit of mathematical magic here. Because in the real world, if you get into chemistry, sometimes if you have different densities of liquid, it's not always true that you mix 120 milliliters and 360 milliliters and get 480 milliliters. Especially if you're doing a solution of alcohol and water. Alcohol will somewhat dissolve in water. So what happens is, I don't want to get into a big chemistry lesson here, but you have your particles of water that are probably a little more random than that, but those are your particles of water. There is some space between them. There's holes between them. And the particles of alcohol, since they're much smaller than the water particles, will actually, a certain number of them can hide in the spaces between the water particles. Kind of like taking a large, a container full of like river rock or whatever. Well, you can take sand. The container can be full of rock, but you can take sand and dump it in there. It'll fit into the holes between the rock. You can add quite a bit of sand to it before the sand will start increasing the volume of what's in there. The same with some of our solutions. Some of our solutions are like that. The alcohol, you can add alcohol to water before it will start to increase the volume. A little bit will go in there before it starts to increase the volume. Okay. So, a couple more examples here that I want you to do. In your notes, I want you to try and find this one. Find the dilution if 640 milliliters of saline are in 800 milliliters of solution. So find that dilution in your notes quick. So a dilution is, again, the ratio of serum to total solution. Do we know the amount of serum? No, but we can find it by doing what? Subtract. 800 milliliters minus 640 milliliters. Do we know the total solution? It's the 800. Very good. So we're going to do our subtraction here. That's 160 over 800. Same units. So we can divide those out. 160 and 800 can both be reduced by 160. Very good. Again, you could have divided by 10 and then by 8 or 2, whatever. Gives you 1 in 5. It's a 1 in 5 dilution. In a 3 in 11 dilution, how much serum and how much saline are required to create $550 milliliters. Why don't you try to tackle that one quick? It's different than what we've seen, but I think you guys can handle it. Okay, so our dilution here is 3 in 11. Again, the 3 is the serum. The 11 is the total solution. Well, we're not looking for total solution, but we have the total solution. We're given the total solution of 550. But are we looking for the serum? Yes, that's actually one of the things we are looking for. So we're going to cross multiply and divide. 11 times 550, or sorry, 3 times 550 divided by 11 gives us 150 milliliters. That is the amount of the serum. Now we could just subtract from the 550 to get the amount of the saline. I don't know why I blacked out there. But I'm going to do this. I'm going to go ahead, I'm going to adjust my ratio here. I'm going to do the ratio of saline to total solution. And I'm going to use that ratio to figure it out so that I can double check later. So if 3 out of 11 parts is serum, the other 8, 11 minus 3 is 8, out of the 11 parts is saline. So I'm going to double check that against my 550 milliliters of total solution. cross multiply 8 times 550 divided by 11 is 400 milliliters. So I'm getting 550 milliliters of serum, 400 milliliters of saline. Does that add up to my total? Yes, it does. So it's doing it that way gives us that ability to add them up to double check a little bit. If we screwed up one of the two cross multiplications, that total wouldn't work out. Doesn't mean we did it all right, but it's a little bit of extra assurance. So what is a dilution used for? Well, it can be used for adjusting the concentration of a solution, which we'll look at probably after break. But another thing it can be used for is for blood testing. Let's say we're doing a blood sugar test. And you take a sample of blood. Let's say you've got a 20 microliter blood sample. And the original sample went off the meter. Your meter is only capable of going up to 800 milligrams per deciliter of blood. If the concentration of blood glucose is higher than that, the meter will not register. It can't read it. So this person has gone over that limit. So what we're going to do is we're going to take this 20 microliter sample and we're going to dilute the 20 microliters of blood with 80 microliters of sterile water. Then we're going to retest it to get a reading. I put it 800. That should be 80. Sorry about that. Not 800. That should be 80 microliters. I'm throwing out extra zeros today. I did that in my last class too. So we retest it. The new reading is 230 milligrams per deciliter. Obviously, that is not the person's blood glucose level because that's been diluted. What is their true blood glucose level? Well, first thing we need to figure out is the dilution. The dilution, of course, is serum or concentrate in this case. So the serum in this case is the blood, which was 200 microliters. The total solution. How much was the total solution? There you go. We had the 80 microliters of water with the 20 microliters of blood. So that gave us 100 microliters. So our ratio, our dilution ratio is 20 microliters to 100 microliters. The microliters again will divide out, same units. Reducing that ratio by 20 gives us a 1 in 5 dilution. That dilution is now used to convert this reading, the meter reading, the diluted reading, to an actual reading, a concentrated reading. So we've got the 1 to 5 ratio. Now I could tell you where to put things here, but I'm going to walk you through the thought process here. Is the actual blood glucose level going to be higher or lower, bigger or smaller than the 230 milligrams per deciliter that our meter read? It's going to be larger. So the bigger number is going to be the actual. So the 230 has to be the smaller number. So it's going to go with the 1 because the 1 is the smaller number. And now we'll cross multiply and divide. 5 times 230 divided by 1, bless you, what was that, 1150 milligrams per deciliter? At what level do they go into diabetic coma? Is it about 1200? Depends on the person. I know 1150 is probably getting kind of dangerous. Similar example to that. Let's say doing a urine test, similar case. Again, we have a meter that has a capacity of 750 milligrams per deciliter. And we've exceeded that capacity. So what we're going to do is we're going to use a 10 milliliter urine sample. We're going to dilute it 1 in 4 with sterile water. After we've done that, the new reading is 198 milligrams per deciliter. So the first thing we need to do here, now at this point, we haven't got this reading yet because we have to prepare the sample. So the first thing we need to know is how much sterile water, how much normal saline do we need to add to this to dilute this down. This is a 1 in 4 dilution, but the 1 is the serum, in this case the urine. The 4 is the total solution. We don't care about the amount of total solution here. We want to know the amount of sterile water, saline here. We want the ratio of the serum to saline. What's that ratio going to be? 1 to 3. Very good. If there's 4 total parts, if one of those parts is urine, the other 3 parts is saline. So we have, where's the 10 milliliters go? That's our serum, or concentrate in this case, right? 10 milliliters there. We will cross multiply and divide. 3 times 10 milliliters divided by 1 is 30 milliliters. So the first thing we needed to know here is we're going to add 30 milliliters of sterile water to that urine sample. Next, we did that. We test it. We get the reading of 198 milligrams per deciliter. So we go back to using the dilution ratio now, the 1 in 4. Where does the 198 go? Top or bottom? It goes on top because the diluted reading is going to be smaller than the actual reading. So the 198 goes with the smaller number, which is the 1. And we shall now cross multiply and divide. 4 times 198 divided by 1 is 792 milligrams per deciliter. Before we take a break, one little warning I should give here. If the error on our meter, we talked about the capacity of the meter being 750 milligrams. If that is plus or minus 5%, when we dilute this, that possible error also increases. This is a 1 in 4 dilution. That 5% error now goes up to a possible 20% error. The error in the reading itself is still only 5%. But since it's been diluted, that means the error in the actual amount is magnified by that dilution error ratio. So just something to keep in mind. So when we're diluting that, in this case, it might have been more beneficial to do a 1 in 2 dilution, which would have still brought us below the meter capability, and it would have kept us, it would only given us up to a 10% error instead of a 20% error. So we'll talk about that more after break. It's time for break, so let's go ahead and do that. We'll come back at 11:32 and start lecturing again.